Okay, we're going to talk about the quadratic formula. And rather than just plug in numbers and solve equations, we're going to derive this equation. Then we're going to look at some special features about this equation that you may encounter when using it. Okay, let's get started. Let's derive the quadratic formula, then use it to solve some quadratic equations. Knowing how to derive this formula helps in understanding the math you'll be using. Many people say I'll never use this stuff, and they're probably correct. But since you and everyone else in the world don't know what kind of job or responsibilities you'll have in the future, it pays to at least learn the basics. Plus, having the knowledge of a few basic high school equations in your head will never hurt your paycheck. You can never tell. The knowledge of the quadratic equation just might be a huge dollar question that only you can answer. Remember, learning math is never a waste of time. Let's get started. So, okay, let's first look at the equation we're dealing with. The solutions of the standard form of the quadratic equation, ax squared plus bx plus c equals 0, where a is not equal to 0, are given by the quadratic formula. X equals minus b plus or minus the square root of b squared minus 4ac divided by 2a. And as you can see, the quadratic formula has the same variables, a, b, and c in it. You can solve quadratic equations by factoring, graphing, completing the square, or by using the above quadratic formula. I've demonstrated factoring, graphing, and completing the square in previous videos. Now, we'll use the quadratic formula. But first we have to derive the formula. As you can see, the quadratic formula contains the same small case letters as the standard form of the quadratic equation. The reason for that is because it is derived from the standard form of the quadratic equation. Small letters are used to represent the coefficients or the numbers in front of the variable x and the constant c. Let's derive the formula. Okay, our formula is ax squared plus bx plus c equals 0. Let's divide the whole equation by a. So we divide a squared, divide through by a each term. So a over a cancels, and we get bx over a plus c over a equals 0 over a. And we end up with x squared plus bx over a plus c over a equals 0. Now, we do is we move the c over a to the right-hand side. Whenever we move something, a term, past the equal sign, we change the sign of that term. So it's plus on the left side. When we move it to the right side, we change it to a minus. Now we complete the square. And what we're doing is, to complete the square, we're going to take 1/2 of the coefficient of x, which is b over a, and then square it. So we take 1/2 of b over a, then square it. And so when we square it, 1/2 of b over a is b over 2a, then squaring it is b squared divided by 4a squared. Okay, now what we do is we add b squared divided by 4a squared to both sides of the equation. Okay, and that's what we've done here. Okay, remember we did this. We took 1/2 of b over a, then we squared. So 1/2 of b over a is b divided by 2a. Then we square it. That's b squared divided by 4a squared. Then we added b squared divided by 4a squared to both sides, as we did here. This equation on the left-hand side is a very special equation. This equation on the left-hand side is equal to x plus b over 2a squared when factored. So essentially, this is the factor of this equation. X plus b over 2a squared is the factor of the equation on the left-hand side. So therefore, we can replace it with that factor. So x plus b over 2a squared is equal to b squared divided by 4a squared minus c divided by a, which is the right hand side. Okay, let's continue. Okay, now let's work on the right hand side of this equation. On the right hand side of this equation, we have b squared divided by 4a squared minus c over a. And we'd like to add these two fractions, but they don't have the same denominator. And as you know, to add fractions, they got to have the same denominator. So in order to give the c over a the same denominator, we got to multiply it by 4a. And in order to multiply it by 4a, we multiply it by 4a divided by 4a. We multiply the top and the bottom by 4a, which is 1, essentially. So that gives us 4a divided by 4a times c divided by a, and that gives us 4ac divided by 4a squared. Now they both have the same denominator, and now we can add them. So the right-hand side becomes b squared minus 4ac divided by 4a squared. Okay, and we can take the square root of both sides, and the square root of any squared number is just, any squared term is just that term. So the square root of the right-hand side is plus or minus. So therefore, we have x plus 2a equals plus or minus the square root of b squared minus 4ac divided by 2a, because up here the square root of 4a squared is 2a. Okay, now we move b over 2a to the right hand side, and once we do that, we got to change the sign. So x equals minus b over 2a plus or minus the square root of b squared minus 4ac divided by 2a. Okay, let's continue. Okay, here's what now last the previous equation. And since they both have the same denominator, we can add the numerators. Okay, so we end up with x equals minus b plus or minus the square root of b squared minus 4ac divided by 2a. And the equation beneath the square root sign, b squared minus 4ac, is called a discriminant. And we're going to talk about that a little bit later. Okay, methods for solving quadratic equations. You can solve quadratic equations like that, ax squared plus bx plus c equals 0 by graphing, factoring, completing the square of the quadratic formula. Graphing always works, but it's useful for a visual effect in approximate solutions. Factoring, sometimes you can use it if you can determine what the factors are. The factors are usually integers. Completing the square always works, is useful for the standard form equation. And the quadratic formula is always the equation to go to. This equation always gives accurate solutions. Let's solve some problems. Okay, suppose you were asked to make a cat litter box using cardboard. The litter box container should have 2-inch high walls. Your veterinarian says a cat needs at least 612.5 cubic inches of litter to fill the box, regardless of the cat size. Let's see how this would be done. Okay, you start off with a piece of cardboard, x units long and x units wide, x units long and x units wide. Okay, because you don't know what the dimensions of this piece should be, you have to calculate this. We do know that because of the 2-inch high walls, we need to cut a 2-inch square from each corner. Okay, now I just made this 2-inch high walls. You can make these walls whatever you want to. Okay, but I'm quite sure you wouldn't want your cat climbing over 5-inch walls to get into a box. But you can make the walls whatever you want to. I just made them 2 inches. Okay, so let's continue. First, we cut out 2 by 2 inch squares from each corner. These flaps, when folded up, will form the walls of the litter box as shown. We first started with a piece of cardboard piece X inches wide and long. Now we subtract the 4 inches from each side because 4 inches were cut away from X. So as you know, previously all of this was X on the top, the right hand side, and the bottom. What we did was we cut 2 inches out of here, 2 inch by 2 inch, 2 inch by 2 inch. So 2 plus 2 is 4. So we subtract 4 from X on each side. And that's how we get the X minus 4. Then if we flip these flaps up, it forms the box as it is here to the right. Okay, let's continue. Okay, so our volume is equal to length times width times the height. Length times the width times the height. Okay, and our length is X minus 4 inches. Our width is X minus 4 inches, and our height is 2 inches. And that's the volume, and that's equal to 612.5 cubic inches per our veterinarian. Okay, so let's multiply that out. So we got volume is equal to X minus 4 times X minus 4 times 2 equals to 612.5. And so we multiply that out, we get X times X is X squared, X times minus 4 is minus 4X, minus 4X times X is minus 4X, minus 4 times minus 4 is plus 16, and we multiply all of that by 2 right there. Okay, so inside of here we add the middle terms. We get X squared minus 8X plus 16. Okay, and that's still multiplied by 2. Then we multiply that by 2. That's 2X squared minus 16X plus 2 times 16 is 32X is equal to 612.5. And then we move 612.5 to the left-hand side, and we add those two terms, and our final quadratic equation is 2x squared minus 16x minus 580.5 equals 0. And that's our quadratic equation, with A equals 2, B equals minus 16, and C equals minus 580.5. Let's continue. And as I said here, A equals 2, B equals minus 16, and C equals minus 580.5. And we know how to solve this quadratic equation now because we had a quadratic formula. But first, let's take the discriminant and solve it. So we plug in B, A, and C into the discriminant, and B is minus 16, so minus 16 squared minus 4 times A times C is minus 580.5. And we do the addition, and we come up with 4,900. So B squared minus 4AC equals 4,900. Okay, so that's our discriminant. So we plug in our discriminant under the square root sign. And so we have minus B, which is B is minus 16, and this discriminant is 4,900, 2 times A, and A is 2, so we're 2 times 2. And so we have X is equal to minus times minus is a plus, so that's 16 plus or minus the square root of 4,900 divided by 4. And so X equals 4 going to 16 4 times. So that's 4 plus or minus square root of 49 is 70 divided by 4. So X is equal to 4 plus or minus 17.5. So X is equal to 4 plus or minus 17.5. So we have two X's, two solutions. So X1, we call that X1 equals 4 plus 17.5. And so therefore 4 plus 17.5 is 21.5. Our second solution is 4 minus 17.5 because we're plus or minus. And so X2 is equal to minus 13.5. Well, we can't use a negative dimension, so our answer must be X1 equals 21.5. Therefore, we begin our construction of the litter box with a piece of cardboard 21.5 inches squared. So all of our x's are equal to 21.5 inches. So from the quadratic equation, we've determined what our x is supposed to be. Okay, let's continue. Now, if our x is 21.5, then x minus 4 is 21.5 minus 4, and that's equal to 17.5. So therefore, our flips are 17.5 inches. Okay? So our volume equals length times width times the height, and our length is x minus 4 times x minus 4 times 2 equals 612, and x minus 4 is 17.5, so 17.5 times 17.5 times 2 equals 612 cubic inches, and quadratic equation 2x squared minus 16x minus 580.5, and if we plug in 21.5 for x, everywhere we have an x, we end up with 0 equals 0, which shows us that we did exactly the right thing for our solution. So for you folks that didn't study and cut classes, your excuse is, I'll never use this stuff. Well, this is how you use the math, and this is why you pay money to those folks who studied. Okay, let's continue our investigation. Let's investigate the solutions to the standard equation. Okay, here's our standard form of equation. Here's our quadratic equation. Here's our discriminant. Remember, the x values are called solutions to the equations and are called roots or zeros of the equation. Either one, solutions, roots, or zeros. You hear that all the time. These are the values where they cross the x-axis. So sometimes the solutions cross the x-axis, sometimes they just touch the x-axis. But we're going to talk about that. The discriminant can be either negative, 0, or positive. This discriminant beneath the square root sign can be either negative, 0, or positive. And we're going to look at that to see why. Investigate that. Let's see why. Okay. A negative discriminant. Let's take an equation that's going to come up with a negative discriminant. So we have 2x squared plus x plus 3 equals 0. A equals 2, b equals 1, and c equals 3. A equals 2, b equals 1, there's a 1 in front of the x, and c equals 3. Now, okay, we take our quadratic formula and we plug in a, b, and c right there. And then we do the multiplication, and lo and behold, we come up with minus 1 plus or minus the square root of minus 23. And divided by 4. Minus 1 plus or minus the square root of minus 23 divided by 4. There are no real roots because there is no real number that can be the square root of a negative number. So there's no real roots to this square root of minus 23. But this equation can be solved. It can be factored. Once you study complex numbers, you'll see that I squared equals minus 1. And if I squared equals minus 1, we introduce another variable in complex numbers, and it's called I squared, and we say it's equal to minus 1. So if I squared equals minus 1, then the square root of I squared is equal to I. So now that we've gotten rid of the minus under the sign, we can find the factors. And I'm going to go through this with you. I want to show you how this works. So don't get lost on me, because I want to show you this and how this works. Even though I'm not going to explain too much complex numbers, I want you to see how this works. So therefore, x is equal to minus 1 plus or minus I times the square root of 23 divided by 4. So therefore, we have x1 is equal to, we have two solutions, x1 and x2. x1 is equal to minus 1/4, 1 divided by 4, plus I times square root of 23 divided by 4. And we have x2 equals minus 1/4 minus I square root of 23 divided by 4. So we have two solutions. Okay, and if we take either one of these solutions and plug it back into 2x squared plus x plus 3, we'll see that it's a solution to the equation. Okay, I'm going to do this one root 1. And I'm going to plug that in and show you how it works. And if you want to see how that second root works, you come out with the same answer. Okay. So substitute root x1 for x. So everywhere in your equation, you substitute root 1 into x. The first term is x squared plus x plus 3 equals 0. Okay. So x squared is that term squared, okay, plus x plus 3, okay. Then you multiply this. Minus 1/4 times minus 1/4 is 1/16, 1 over 16. Minus 1/4 times I times the square root of 23 over 4 is minus I times square root of 23 divided by 16, because 4 times 4 is 16. Okay. Plus I square root of 23 divided by 4 times minus 1/4 is minus I times square root of 23 divided by 16. 4 times 4 is 16. And plus I times the square root of 23 divided by 4 times I square root of 23 divided by 4 is I times I is I squared. Square root of 23 times square root of 23 is 23. And 4 times 4 is 16. And then you add up these terms inside. And you add up all of these terms inside. You change these terms over here so they can all have the common denominator, like we did previously. And you continue on and add up all the terms. And what you'll see is you come up with minus 22/8 plus 22/8 equals 0. And so what happens is, because this equation does not have any real roots, 2x squared plus x plus 3 equals 0, because it has no real roots, the square root of minus 23 says that when the discriminant is negative, it indicates that the graph does not cross the x-axis. So it shows that this graph does not cross the x-axis. I'll leave the other root for you to check as an exercise. But I wanted to go through that with you so you can see it. Okay, let's continue. So, okay, that explains why when you have the square root of a negative number in this quadratic formula, that it doesn't cross the x-axis. And you can see the quadratic formula represents a parabola. Okay, let's continue. Let's check x squared plus 8x plus 16 equals 0. Well, as we did before, a equals 1, b equals 8, and c equals 16. And our discriminant is b squared minus 4ac. We plug all of those numbers in, and we get 64 minus 64 equals 0. So therefore, our discriminant is 0. This is called a perfect square. It has one solution. It is also called a double root. And I'm going to show you why that is. Because it is a perfect square, it can be factored easily. When the discriminant is a perfect square, it indicates that the graph just touches the axis. It doesn't cross, it just touches. So x squared plus 8x plus 16 is equal to x plus 4 times x plus 4 equals 0. And if you set each one of these equal to 0, you get x equals minus 4, because you move the plus 4 over to the other side and change the sign to minus 4. So x equals minus 4 is the root. And it's called a double root because you have two of them. This is called a perfect square. It has one solution. It is also called a double root because it is a perfect square and can be factored. And here it is. Okay. X squared plus 8x plus 16 equals 0. And you can see it just touches the x-axis at x equals minus 4. Okay. Let's continue. Here's another root. 2x, here's another equation, I'm sorry. 2x squared plus 6x minus 7. And as before, we'll go A equals 2, B equals 6, and C equals minus 7. We plug in our numbers, and we do the multiplication, and we get the discriminant equals a 92. Take the square root of 92, so that's minus 6 plus or minus the square root of 92 divided by 4, okay? And 92 is equal to 4 times 23, okay? So we subtract, we have x equals minus 6 plus or minus 2 times the square root of 23 divided by 4. And 2 go into 4 2 times, 2 go into 6 3 times, so that's why we get to minus 3. And 2 go into 4 2 times, and 2 go into 2 1 time, so that's why the 2 disappeared. So x is equal to minus 3 plus or minus the square root of 23 divided by 2. So we have two roots. We have a double root, x1 and x2. x1 is minus 3 plus square root of 23 divided by 2. Root 2 is minus 3 minus square root of 23 divided by 2. Let's see the graph. This equation's roots are irrational, meaning the roots cannot be written as integers. Okay. So if we do the multiplication on root 1 and root 2, we'll see x1 is equal to 0.8979, and x2 is minus 3.8979. And if you look at the graph, you'll see that the roots, the graph crosses the x-axis at 0.8979, and it crosses at minus 3.8979, and it crosses the y-axis when x equals 0 at 7. Right here, at x equals 0 is minus 7. Okay, so the graph shows everything about it that you need to see. So let's look at another problem. Okay, and this is a word problem. The reason why I'm showing you these problems is because I'm giving you just different scenarios of how the quadratic equation is used, so when you come in contact with it, you'll understand how to use it. So this is a function that models this ride. When I say it models it, means it won't give an exact solution because it wasn't derived exactly for this scenario, but you can get a pretty good feel about the numbers or whether they're reasonable or not. Okay, but as you can see, this is a parabola. Okay, this equation models a parabola. So where h is equal, here, let me read through it. An amusement park ride shuttles riders to the top of a tower and drops them at speeds reaching 80 feet per second. A function that models this ride is equal to h equal minus 16t squared minus 64t plus 60, where h is in feet and t is in seconds. How long does it take riders to drop from 60 feet to 0 height per this quadratic equation? Okay, well, if you look at this quadratic equation, you can look at h is equal to this equation. If you put t equals 0, you can see that it starts out at 60 feet. Okay, and that's what it says here, 60 feet. So at t equals 0, it starts out at 60 feet. Okay, let's apply our quadratic formula to this equation. So set h equals 0, because that's what it says, drop to 0, height. And then we have our quadratic formula here. Now solve the quadratic equation for t. So what we do is we have A equals minus 16, B equals minus 64, and C equals 60. And then we take our discriminant, we plug in our numbers, and we come up with our discriminant equals 7936. So, okay. And we did all of the calculations. We come up with our discriminant 7936. So we have 64 plus or minus 7936 minus 30 divided by 32, minus 32. Okay. And we get two solutions. We get t equals minus 2 plus minus 2.78 equals minus 4.78, and t equals minus 2 minus a minus, which is a plus. So minus 2 plus 2.78 is equal to 0.78. So therefore, since t equals minus 4.78, we don't need that one. We don't need a negative time. So therefore, t equals 0.78 is a reasonable time to drop from 60 feet. Let's take a look at the graph. So if we look at the top of the graph is locates the vertex. And from, if we remember, when we were completing the square, we took 1/2 of the term in front of the x. Okay, we said 1/2 of that. So we have minus b over 2a. That's 1/2 of that term. So we took 1/2 of that. Minus times a minus is a plus. So that's 64 plus 64 divided by 2 divided by minus 16, which is a is minus 16, 2a. And we get t equals minus 2. If we plug in minus 2 into the equation, you get h equals 124. So to locate the vertex is at minus 2, 124. At t equals 0, we see that the graph crosses at h equals 60. As you can see, the parabola crosses the y-axis at h equals 60 when t equals 0. Let's look at the bottom part of the graph. The bottom part of the graph is, here's the two ends of the graph crossing the x-axis. One crosses at 0.78, the other crosses at minus 4.78. That's the two solutions. And in the middle is minus 2, as we calculated before. You can see the parabola crosses the x-axis with t equals minus 2 at the middle from 0. Only the positive value for x at the crossing is reasonable. That's over here, 0.78. Let's do one. Okay, let's do a smoking problem. A decrease in smoking in the United States has resulted in lower death rates caused by lung cancer. The number of deaths per 100,000 people, y, can be approximated by y equals minus 0.26 times x squared minus 0.55 times x plus 91.81, where x represents the number of years after 2000. Okay. So the problem requires us to calculate the number of deaths per 100,000 people for the years 2015 and 2017. That's 15 years after 2000 and 17 years after 2000. Use the quadratic formula to solve for x when y equals 50. And C, according to the quadratic function, when will the death rate be 0 for 100,000 people? Do you think that this prediction is reasonable? Okay, let's solve it. Calculate the number of deaths per 100,000 people for 2015 and 2017. So what we do is we substitute 15 for x. And since x represents the number of years after 2000, we substitute 15 for x. So everywhere we got an x, we put a 15, and we do the multiplication, addition, and subtraction, and we get y equals 25.06. So in the year 2015, 25 deaths per 100,000 people. That's what the equation, the model predicts. Okay, for 17, we substitute 17 everywhere we have an x. Okay, and so we do the multiplication and then the mathematics, and we come up with 7.3, so 2. So in the year 2017, there's 7 deaths per 100,000 per this equation. Okay. Use the quadratic formula to solve for x1, y equals 50. Okay, so what we're going to do is we're going to make y equals 50. Okay, and y represents the number of deaths per 100,000. And we want to see when y equals 50, what x will be. So what we do is we substitute 50 for y, then we solve for our differential equation. We move 50 to the other side, subtract it from 91.48. And we get our equation A equals minus 0.26, B equals minus 0.55, and C equals 41.81. Okay, and we apply these constants to our quadratic formula. Okay, and we calculate our discriminant, and we get our equation is equals 0.55 plus or minus square root of 43.785 divided by 2 times minus 0.26. And we get 2 solutions as previous. We get x1 and x2. And if we do the multiplication for both solutions, we get x1 equals 11.67, or we get x2 equals minus 13.76. Well, we don't need a negative number, so we take the x1. So in the year 2011, the number of deaths per 100,000 will be 50 per this model. Okay. According to the quadratic formula function, when will the death rate be 0 for 100,000? And do you think this prediction is reasonable? Well, in order to make that 0, we set y equals 0. And then we solve the same quadratic formula. Okay. And we get 2 solutions again. Okay, x1 and x2. And if we do the multiplication and addition, we get x1 equals 19.88, and we solve x2, we get x2 is equal to 17.76. Well, x1 is minus 19.88. Well, we don't need we can't use a minus number. That does nothing for us. So x2 equals 17.76. Well, it's approximately 18 years. So in the year 2018, deaths per 100,000 is 0 per the equation. According to the quadratic function, when will the death rate be 0? Well, per 100,000 people? Well, we found that out to be, we discovered that from the equation to be 2018. Do you think this prediction is reasonable? No, it's not reasonable, because a cure for cancer is needed to eliminate all deaths from cancer. Equations can't predict a cure for cancer. Okay, let's continue. And this is where I retrieved some of that data from tobacco, and so if you want to look up your state or so forth, you can go here. Okay, let's continue. Okay, good students derive formula. They don't just memorize. And I went through this quadratic equation with you in a lot of detail, so I want you to see how to apply it to different equations and what it means when you get certain answers. And that's how you understand the quadratic equation, and I hope you understand it much, much better. For those folks who think you'll never use this mathematics, well, that's why you pay the folks that do. So I hope you learned something. Until next time.